Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. 50 questions and answers about space-time. Bending reality one question at a time. 1. What is space-time? Space-time is a four-dimensional continuum combining three dimensions of space with one of time, first described by Einstein's theory of general relativity. 2. How did the concept of space-time originate? It originated with Einstein's theory of general relativity in 1915, which unified space and time into a single, interconnected framework. 3. What does fabric of spacetime mean? It's a metaphorical term describing how spacetime behaves like a flexible, stretchable fabric influenced by mass and energy. 4. How does mass affect spacetime? Mass causes spacetime to curve or bend, altering the path that objects and light take through it. 5. What is general relativity? General relativity is Einstein's theory that describes gravity not as a force between masses, but as a curvature of spacetime caused by mass and energy. 6. Can we see the curvature of spacetime? Indirectly, yes. Observations like gravitational lensing show how light bends around massive objects, reflecting spacetime curvature. 7. What is gravitational lensing? Gravitational lensing is the bending of light by a massive object's gravity, demonstrating how mass affects spacetime. 8. How does time behave near a massive object? Time slows down near massive objects. This phenomenon is known as gravitational time dilation. 9. What is a black hole in terms of spacetime? A black hole is a region where spacetime curvature is so extreme that nothing, not even light, can escape. 10. Can spacetime tear or break? Theoretically, no. However, ideas like cosmic strings or spacetime singularities hint at extreme conditions. 11. How does speed affect spacetime? High speeds lead to time dilation and length contraction, effects predicted by special relativity, which deals with uniform motion. 12. What is the event horizon of a black hole? The event horizon is the boundary in spacetime beyond which no information can escape from a black hole. 13. Does spacetime have an edge or boundary? In standard models, spacetime is considered infinite or wraps around in a closed universe, so there's no edge. 14. What happens to spacetime in the Big Bang? The Big Bang is described as an expansion of spacetime from an infinitesimally small, hot, and dense state. 15. How do wormholes relate to spacetime? Wormholes are theoretical passages through spacetime that could connect distant points, though they're purely hypothetical. 16. Can spacetime be flat? On large scales, if there's no significant mass/energy, spacetime can be considered flat according to general relativity. 17. What is spacetime inflation? Inflation refers to a period of extremely rapid expansion of the universe shortly after the Big Bang, Smoothing out spacetime. 18. How do gravitational waves interact with spacetime? Gravitational waves are ripples in the fabric of spacetime, caused by some of the most violent and energetic processes in the universe. 19. What does it mean for spacetime to be quantized? Quantization of spacetime suggests that at the smallest scales, space and time might come in discrete units, a concept from quantum gravity theories. 20. How does dark energy affect spacetime? Dark energy is thought to contribute to the accelerating expansion of the universe, stretching spacetime more rapidly. 21. What is the cosmological constant? Originally introduced by Einstein, the cosmological constant could represent dark energy, contributing to the expansion of spacetime. 22. Can spacetime have negative curvature? Yes, negative curvature means space is saddle-shaped, and this would lead to an infinite, open universe. 23. How do we measure spacetime curvature? Through observations like the bending of light, gravitational time dilation, and the motion of planets and stars. 24. What is the role of matter in spacetime curvature? Matter and energy tells spacetime how to curve, and in turn, the curvature of spacetime tells matter how to move. 25. What are spacetime singularities? Singularities are points where spacetime has infinite curvature, like at the center of a black hole or the Big Bang. 26. How does light travel in curved spacetime? Light follows geodesics, the shortest path in curved spacetime, which can appear curved from an outside perspective. 27. What is the equivalence principle? It states that the effects of gravity are indistinguishable from the effects of acceleration, fundamental to general relativity. 28. How does general relativity differ from Newtonian gravity? General relativity describes gravity as spacetime curvature, while Newtonian gravity treats it as a force between masses. 29. What is frame dragging in spacetime? Frame dragging is where rotating masses, like Earth, drag spacetime around them, affecting the paths of nearby objects or time itself. 30. How does spacetime affect GPS systems? GPS satellites must correct for both general relativistic effects, time dilation due to Earth's gravity, and special relativistic effects, due to their high speed. 31. What is the twin paradox in spacetime? One twin travels at near light speed, aging less than the stationary twin due to time dilation effects in spacetime. 32. Can spacetime expand faster than light? The expansion of spacetime itself can exceed the speed of light, as seen in cosmic inflation or current dark energy-driven expansion. 33. What is the significance of the Schwarzschild radius? It's the radius at which the escape velocity equals the speed of light, defining the event horizon of a non-rotating black hole. 34. How does spacetime curvature explain Mercury's orbit? General relativity accurately predicts Mercury's observed anomalous precession, which Newtonian physics couldn't fully account for. 35. What is a light cone in spacetime? A light cone represents the path light could take from an event in spacetime, defining the causality boundaries for that event. 36. How does mass-energy equivalence affect spacetime? E equals mc squared means mass and energy are interchangeable, and both contribute to the curvature of spacetime. 37. What is the Penrose diagram? A Penrose diagram is a two-dimensional diagram that captures the causal structure of spacetime, particularly useful near singularities. 38. How does quantum mechanics challenge our understanding of spacetime? Quantum mechanics suggests spacetime might be quantized at Planck scales, leading to theories like loop quantum gravity or string theory. 39. What is the holographic principle in relation to spacetime? It suggests that all information contained in a volume of space can be described by a theory on its boundary, impacting our view of spacetime dimensions. 40. Can we travel through spacetime? In principle, yes, through time dilation effects or theoretical constructs like wormholes, though practical travel is far beyond current technology. 41. What is the role of time in spacetime? Time is not separate but an integral dimension alongside space, affecting how events are ordered and how objects move. 42. How does the concept of spacetime change our understanding of causality? Spacetime introduces causality in terms of light cones, where events can only influence or be influenced by others within their light cones. 43. What does spacetime interval mean? The spacetime interval is a measure invariant under Lorentz transformations, representing the distance between two events in spacetime. 44. How does spacetime relate to the arrow of time? The arrow of time might be linked to the second law of thermodynamics, increasing entropy in an expanding universe, giving time direction within spacetime. 45. What is the significance of the Planck length in spacetime? It's the scale at which quantum effects of gravity become strong, potentially where spacetime's quantum nature becomes evident. 46. How does spacetime relate to the multiverse theory? Some multiverse theories suggest different regions of spacetime might behave as separate universes with different physical laws. 47. Can spacetime be manipulated? Theoretically, through exotic matter with negative energy density for concepts like Alcubierre drives, but practically, it's beyond current physics. 48. What is the Kerr spacetime? Kerr spacetime describes the geometry around rotating black holes, introducing frame-dragging effects. 49. How do we detect spacetime curvature? Via experiments like the laser interferometry of LIGO, which detects gravitational waves by measuring spacetime's stretching and squeezing. 50. What's the future outlook for understanding spacetime? Advancements in quantum gravity, more precise gravitational wave detection, and possibly space-based experiments will further our understanding, potentially reconciling quantum mechanics with general relativity. These questions and answers provide a broad overview of spacetime, touching on both foundational concepts and cutting-edge theoretical physics.